Hello, everyone. Thanks for joining for the AI agents session. And thank you for the audience who are here and also for folks who would be watching on demand later. I'm Kanch. I'm a technical solutions manager in the applied AI engineering team. In our team, we work with customers all together, like the folks who are here together. We talk to at least 50 customers a week, try to understand the patterns of problems and build solutions across. We are happy to be here and share a little bit of what we have learned and what we have built. Melton?
Yes, thanks, Kanch. And hi, everyone. My name is Maltam. I'm in the same team as Kanch. I'm a senior generative AI solutions architect there. Joined Google last year. And yes, I'm happy to talk today about agents and work your hands on through a couple of demos.
Heiko?
Hi everyone. Hi, I'm Heiko. I'm a generative AI black belt. I work with our most strategic customers to make sure they are successful in their Gen AI journey on Google Cloud. And I've been here at Google for almost a year now.
Thank you both. It would be remiss of me not to, thank my moderators, Alan Blount, Hussein, and Fabian, who are with you answering questions as we move along. So thank you, everyone. Here we go. So in the rest of the 45 minutes, this is what we have planned for you. We'll start with some theory. It's going to be like pretty higher level, understanding what's an agent is, multi-agents, things like that. But then we will go deep into the code immediately. Malcolm would be walking you through the code and sharing multiple options and for you to be able to, experiment it yourself. And then towards next, we would talk about how you could start thinking about experimentation and evaluation for your use cases. And we'll close it out with some key points which we think would be valuable as you start experimenting in the agent space. So let's jump into theory. Long ago, so long ago, it was November 2022, and we all came into this world of foundation models. So what happened at that time? So let's just have an imaginary thing. Like here, I want to go to Shangri-La, Paris. In the early days, there were only models. And we were like, it's a simple LLM call. And as you could see, there is prompt and probably some context related to the organization or anything else, and a foundation model call. That's about it. And then we went a little bit further when we realized, oh, I need more. And in this question, I'm asking, find me directions to Shangri-La, Paris from a specific address. So to accomplish that, we introduce the concepts of tools. So tools here in this case at Maps, it could be anything. You could define your own tool for your own organization. So then came tools. And then there was a concept of, hey, I need to bring my data to make it work. Here, another simple example, find me directions to Shangri-La, Paris from my home. My home is my information, and that's the address you have for retrieval augmented generation. Pretty, simple. Now comes a little bit complicated. Here, I'm asking to book me hotel and flights near Shangri-La, Paris that is pet friendly, no smoking, and has availability in both my and my friend's calendar. It has a lot of things going on here. First, you need the tools. Then you need the grounding with the specific address. And you need my calendar, my friend's calendar, and you need some filters to make it work. You need the availability of the hotel, flights, so many things happening here. So it needs a complex agentic architecture. But before we jump into it, let's just first demystify what is a foundation model and what is a agent. So first we need to understand what is a foundation model. A foundation model is, as you could see, it's a large pre-trained model based on, massive data sets, which we all know of, and it can perform a wide range of tasks. Doesn't necessarily relate to the task which you want, but it could do a lot of tasks. And it can be fine-tuned, it can be, did additional training, and it reacts based on what it has learned, based on the patterns it has observed. What foundation models are not, and again, I want to classify this by saying some models are evolving. So it is, as of today, it is not a fully autonomous system, nor is it a decision making expert. It doesn't connect to external systems or environment unless you architect it in certain way, and it does not maintain a context or long term memory or any of that. So first, understanding when to use a foundation model and when to use an agent is would be helpful when we are starting to think about designing an application. Now we move to, okay, let's start defining what is an agent. When you think about a generative AI agent, um, it's like the IQ, EQ, AQ. Um, there was a concept of chatbot. It is great, but what we really need is reasoning, a planning, memory, tools, etc. So when we think about agents, how do we evolve it to? First came, I want to connect with my data, and that's the RAG approach, which we saw. And then we talked about, connect to my APIs, because most enterprises or organizations are very reliant on their APIs or tooling information, which is needed. And it needs to be grounded to the proprietary information. And they want to be able to orchestrate across multiple ones. And defining a persona for an agent, like what it is going to do, what does a profile look like, what is the intention of these agents, how do we specify the prompts, instructions, etc. So in my view, an application is that reasons how best you achieve a goal based on the outcome. And in this case, as you could see, the generative AI model is one. And then you have the agent anatomy, where you have the profile, goals, memory, which is short term, long term, episodic, things like that. And then there is model based reasoning and planning, which makes an agent an agent. The tools, as you could see here, again, it's APIs, it's your data, it's your functions, or it could be another agent. It doesn't have to be restricted to a particular thing. But then now we go to this we have defined is a single agent. But most organizations have complex applications to be designing for. So that's when the evolvement of multi-agent came. And in this case, as you could see, there is one agent, and then there are multiple agents it's talking to. But in this case, consider it like a router, an orchestrator. The central agent you see in there is responsible for delegating the tasks, receiving the tasks, and giving the response back. This is one pattern, and we see multiple patterns in this, and we are not going to be talking more about these patterns. With the 45 minutes, we can only do so much, but there are multiple multi-agent patterns that are evolving. Another one could be a simple sequential orchestration, like from this agent to the next agent to the next agent. Very straightforward. Like first we understood what is an agent, and then we went to, hey, how do I define a multi-agent? And then in the multi-agent, it's like there could be multiple patterns. We took two simple approaches. One is having an orchestrator, being able to delegate, and then there is a sequential orchestration. But what happens with these complexities, with these agents? Like whether it's single agent or multi-agent, the complexities remains the same, because you still have to worry about monitoring, still have to worry about observability, like all of the things which we are all used to None of these concepts are new. If you have developed some things in the past, like, in a software development cycle, we all have, experienced it, gone through it. And Heiko and Malcolm will walk through some of the challenges and how you would be able to overcome it, or suggestions to, improve them. But these, having a safeguard, having a guardrail, having how do you have a tool discoverability? How do you have a agent discoverability? How do you collaborate between agents? How do you handle request response? What does the open schema look like? How do you identify tooling? All of this is pretty much a complexity or things which we need to watch out for. But let's take a moment here. Like, I defined agent, and I try to, say, hey, this is the tools, these are the functions, these are the data. And you might be thinking, hey, you missed out on a couple of things. You didn't mention about this collaboration. You didn't mention about some other topic. Pretty valid. And that's one of the main reason I actually refer to this Andrew Ng's post, which says, we don't have to agree on what an agent is, because all of us have, or a secret, like even in the team, we have several different arguments on what an agent is. But the concept of it is giving the foundation model an extra ability to be able to perform the things which it doesn't currently have, is a good enough definition, I think. But we don't have to agree on what an agentic pattern is, but how you would be able to develop it is where we are going to focus on today. So I want to build an agent in Google. And how do I start? So the first one is, it's pretty straightforward. I want to build a chatbot conversational use case. Pretty straightforward, deterministic use cases, but has generative AI to it. Then I would suggest using Dialogflow. A Dialogflow or conversational agents is a natural language platform built on generative models that can control conversations and flows, and can be used for explicit conversation control. That's one. That's pretty straightforward. But we won't be talking much about the chatbots. But this is one thing which we have referenced in the resources, and we would like for you to be able to go and check it out if you would like. And then there is the next piece of it, which is, I have done agents using open source tools. It could be LangGraph, it could be Crew AI, AutoGen. How do I use Google Cloud for that? That's when Reasoning Engine comes in. Reasoning Engine is a managed runtime for your agentic workflows in generative AI applications. The service, what it provides, it provides your security, privacy, observability, like all the platform related stuff with the benefits of Vertex AI integration. Then comes the next one, which is like, you know what, I don't need all this. I just need the model, and I want to add some agentic behavior with access to tools and to be able to build it. And that's when you would use Gemini with function calling, control generation, extensions, things like that. Couple of things. Today, we'll be very much focusing on the Vertex AI reasoning engine and the control generation extensions pieces of it. But of course, we have shared the resources for you to be able to experiment the rest. One thing before we start, what is an extension? A Vertex AI extension is just a structured API wrapper that connects your model to an API for processing real-time data. So the difference is, extensions and functions is the execution of a tool. Extensions automatically executes in Vertex AI, whereas in functions, you need to manually execute in your logic, and both you would see it pretty much. And now I send it to Malcolm to be able to showcase. Malcolm?
Thank you so much, Kanch. Yes, so before we dive in hands-on, maybe quickly an overview of what we'll be seeing. So Kanch walked us through what an agent is and also what options you have to build your agent. What I would like to do, because most of you know there's a lot of different stuff out there, right? There's a lot of different toolings, a lot of open source solutions, frameworks. What I would like to do here is take one step back so that we really understand the working mechanisms of the agents, the underlying groundworks. Hence, here with the demos, you're not opting for a framework that's abstracting some stuff away, but rather we're going to look into the capabilities really in a kind of DIY approach to really understand how these things are working, and also to get a sense about the underlying challenges, so that we really understand how it works and also what makes it difficult. So I have two demos today. The first one is going to be single agent. The second one is going to be multi-agent. For the single agent one, we're going to work through grounding with Google Search, grounding on your own data with Vertex AI Search, function calling with Vertex AI extensions and API calls, and also looking into a long chain agent with Vertex AI Reasoning Engine. The second demo will then walk through Gemini with control generation. So we're going to do function calling DIY, also to understand how we handle the tool and the function calls. And we're going to explore a multi-agent setup with different tools, including Vertex AI Search, Google Calendar, and Google BigQuery. All right, let's switch to the first demo here. So starting with single agent. Before we go to the agent, let's first understand function calling capabilities and how you would do grounding here. So you already saw this one. I want to build an agent. I'm going to skip the prerequisite steps here because I already installed all the libraries that we need. I restarted the current runtime. So let's go ahead and re-authenticate. That's done. Setting our project, meaning our Google Cloud project ID and the region. Importing the libraries here. So we're going to use the Vertex AI library. Further importing libraries, and then we can jump right into defining our model. So we're going to use Gemini 1.5 Flash for this demonstration. We're giving it the system instructions. You're an assistant that helps me search things. Please be accurate. So very generic. And of course, you can also provide different generation configs. In this case, we're setting the temperature. What we want to do next is you want to utilize the Google Web Search as a tool for our model. So in this case, you could call it agent, you can call it model. It really comes down to the definition, what Kanch mentioned. Some call it an agent already because it has a tool. So I'm going to continue with this terminology and call it an agent here. So we're going to give our agent a prompt, what is the capital of India? And we're going to include the Google Search tool using the tool class for grounding, and then giving this to our model in generation time. So we're giving the prompt, we're specifying the tool, we're giving the Google Search tool as well. And then let's see what's going to happen. So we're getting the response back. The capital of India is New Delhi, and etc. That's for how easy it is to connect web search capabilities. Now let's look into how you can do RAG with Vertex AI Search. There's two different means on how we can do it, which I want to highlight here. So of course, for both, we would need a search app, meaning you can go to the console, you can check out Vertex AI Search there. Usually what you do is you generate a data store where you also upload all of your own data and documents or whatever you want to index there. And then on top of it, you create an app. So we're fetching the app ID there from the console, putting it in here. And once this is set up, we can simply connect this with a retrieval tool, give our data store ID here, the project that we're using, along with the location. And then we can very quickly give this as a tool to our agent, along with a prompt, and see what it's saying. So in our case, it gives us the answer. The operating income for Alphabet Inc. is in the first quarter of 2024 was this much. So essentially, it's now able to work out and ground on our own data. The other way we can do this is through extensions. So Kanch already highlighted what an extension is. Essentially, we have preset extensions that you can use, like the code interpreter, or also Vertex AI Search coupled as an extension. So instead of using the retrieval tool, you can also use it as an extension here. So you just define the same game, the data store with its search app ID here for our extension. Then we create the extension here so that we get the handle, we get the extension name. And once we have it, we can pass it to our agent, which we'll do in a second. The other thing I want to do is I want to create another tool for my agent to use. So in this case, let's go and define the Google Query info as a Python function. We have this function, as you can see here. So query is the quarterly reports from Alphabet, and we're going to use the extension embedding in here. Let's see if I run it. So that's good. And the next function, so that was to include the extension. This one is to get the exchange rates. So the latest exchange rates via an API call. We have this function defined as well. What we do next for function calling, so we have our functions defined. These can be Python functions. These can be APIs that you're using. Once you have them, you need to declare, or you need to prepare the function declaration in an open API schema. So this is for the agent to really understand what your function is about, how it executes this tool, essentially what is needed for the arguments. So we're just going to go ahead and do this here using the function declaration class. Essentially, we're doing the function declaration for the two functions, for the exchange rate and querying. And once we have that, we can pass it as a tool and then pass these tools to our agents. So we can test it out in here, and I'll now show you how function calling essentially works, because that's different from what you would maybe expect from the abstracted away frameworks that you're using. Because in this case, your query will be given the prompt, what is Google's operating income in 2024? And then we're passing this to the model along with the tools that we defined. And what we will get back, and this is for means of, for us as the user, for having full control over this, is where the model is giving back the function to call. So you can see here that the JSON response you're getting is, the part is not a text. So if it was a normal answer, we'd just get a part as a text and then the response. But in this case, to indicate to us that there is a tool that's needed to essentially answer the query, we're getting the part function call back. So what the model is doing, it's auto-populating essentially the name, the function name, and the argument fields for us. And then we as the users would grab this logic and in our code execute the function so that we have control over how the function should be executed, who should execute them, and to have some other guardrails integrated into it. So this is for cases where we don't really want the model to just run around wild and execute the functions. That's how function calling is working. I'm going to skip these two prompts. I also quickly want to look into LangChain. So we have vertex reasoning engine that supports multiple OSS frameworks as well, including LangChain. What we can do here is you can easily create a LangChain agent, as you can see here, with just a few lines of code. So we're using the reasoning engines library, we're creating a LangChain agent class, we're specifying the model, we're giving the tools that we created above. We can enable tracing here, and that's it. The agent is all set up. So we can go ahead and query it in here. And of course, no good demo without an error. Let's try if the other one's working. No. Yes, it seems that I failed running the pip install with the LangChain Google Vertex CI. So I'm going to skip this because the pip installs take a lot of time. But if I did this correctly, what you would see here is the agent giving out the answer directly. So that's in comparison to what we had above, where we're getting the function to execute back. The LangChain agent is executing it directly and answering our questions. All right, what I can now also not show you because I didn't miss to do the pip install is the deployment, which is also fairly easy. So I'm just going to show you the lines of code here. Essentially, once you created your LangChain agent, what you can do is you can use a reasoning engine to essentially deploy it. So once it's deployed, this execution will take a few moments. Once it's deployed, you'll get an endpoint that you can use to interact with your agent so that you can also call your agent from other environments. So that's pretty handy. All right, that's for the first demo with a single agent and walking through function calling. The second thing I want to show you is, before jumping in, let me show you the architecture. It's a bit more complex and that we explored more multi-agent setup scenario. And also in here, we saw that you can have different flows if you set up multi-agent systems, right? You can have a sequential flow, but in our case, what we chose to do is instead having this orchestration or routing LLM layer. So what you see in the middle is we have the agent orchestrator, who then has essentially, you can call them sub-agents connected as tools. So we have an inspection agent with a tool analyze images that can analyze incoming images. We have document agent that's connected to two different databases, essentially, with documents for maintenance manuals and the other one for annual safety reports. We have the scheduler agent then, who can look into our employees database to find employees who have the right license, and also is connected to different calendars. So what it can do essentially is then to look for the employees' availability. What we also tested out is in a supply chain scenario, of course, having an agent that's essentially outside of our organization that lies at a supplier that can give us information about the bill of materials and all of the tax information, essentially. We're going to skip this part for today's demo. So we're going to focus on this one, and I will show you how we set this up solely using Gemini's control generation feature. All right, let's get into it. Before we go into the nitty-gritty details and the backbone of this, I want to show you the demo first here. So we have the front end. I also pulled up the terminal in here so that we see in real time the trace, what's happening. And yeah, let's just directly get started. So what I'm going to do now is I'm going to put an image in here. I'm going to quickly show you the image. So this is an image of an airplane wing with a broken flap. And I want my inspector agent to essentially analyze if there's any damages in this image. Also note here that the inspector agent, it wasn't trained on these images. So it's essentially a zero-shot prompting what I'm doing here. So I'm going to load this in here. I'm going to click on Analyze Image. And then what's going to happen is that the orchestrating agent, who is my main point of contact, essentially as the user, is going to look into it and say, okay, what is needed from me? So the user wants me to analyze the image. That means I should execute the inspector agent, which then the orchestrating agent hands off to the inspector agent. The inspector agent then understands what is asked of it and says, okay, to redo this, I need to execute the function analyze image. So you see here that it identified this correctly. Then we're getting the function response back from the analyze image function. This is then being fed to the inspector agent, and the inspector agent is generating a summary for the orchestrating agent. Then the orchestrating agent is tasked with answering our questions. So as you can see here, it says the analysis of the image gave that the TL2000 Stingsport aircraft wing is damaged. All right, so that seems to be working with the routing. Now, in this case, fingers crossed, that a few things are breaking because I really want to show you the challenges in here and the learnings that we have. But let's see if everything's working fine or if we see any bugs in here as well. So let's ask this question. So I need more info on the aircraft. What do the manuals say about engine maintenance? Would you recall, let me go back to the architecture. So we have the agent orchestrator. We just pinged the inspection agent. And I want the agent orchestrator to understand, okay, this is a task for the document agent. And the document agent needs to know that this question relates to maintenance manuals. So it should ping the correct function for us. Let's see if this is working. So we're asking the question. We're seeing the internal response of the orchestrator. So it's saying, get me the maintenance manuals here, executing the document agent. The document agent understands it's a question on the TL2000 Stingsport. So it's going to look into the maintenance manual. So it's executing the function search manual with the correct arguments in it. We're getting the function response back from our Vertex AI search database, essentially. And yes, this is what I hope for. So as you can see here, we got it back. It's giving it back to the inspector, so the document agent. And then it had one more run before we got the answer. So it failed to understand that it already answered the question, essentially, and can get back to us. So it's triggering the same run again in the backend. For us in the front end, for the user, it doesn't really matter much, except for maybe latency requirements. But you can see here that something happens, so it's running it again. So I'm going to highlight this in my conclusion to really describe the challenges with this. But essentially, this is something that happens in multi-agent systems. You really need to look out for the different agent interactions. So instead of having like a single agent that does things, you now really need to figure out the communication patterns between the different agents, and also understanding, okay, how do I handle it if it fails to recognize that the question has been answered? So I don't want it to loop over and over again, and I have to have some guardrails embedded on top of it. All right, but let's continue with our next question here. So let's say I need someone for engine maintenance. In this case, we would expect it to call the schedule agent, which it does. So it understood I'm asking for a proper personnel to do the job. The schedule agent, also understood that I'm looking for someone who can do engine maintenance. So it's executing the function get employees, where the function essential looks into my BigQuery database here to see what employees do I have and what's the specialization. So in our case, engine maintenance should be the job of John Smith. Let's see if it got that right. So I'm seeing John Smith in here. So it understood, okay, John Smith is the proper person to do engine maintenance. Now let me check John Smith's calendar and see what the next 3 available 1-hour slots are. So it's calling the get upcoming events, the calendar API, and then we're getting the response back. So the orchestrating agent then answers, okay, the next 3 available slots for John Smith are on, let's see, December 5, 10, or basically all day that day. Let's see if it's true. There is availability. So that seems to have worked. Okay, one last question before we look into the backbone of this. Let's say, can you give me some general info about the safety reports? And now let's see if the document agent can figure out that this is not relating to the Sting sport. And yes, perfect. So it's behaving as expected. What you can see here is that the orchestrating agent, see, and let's wait a second. Let's see if it gets the error back. Oh yeah, it didn't even propagate the error. So that's the other thing here that we need to be aware of whenever we design multi-agent systems. So we have the context of the chat session that we populate over. We have been talking a lot about the TL Sting sport in this case. So I'm asking about safety reports. From a topical perspective, these can relate to the Sting sport. But in my case, these are independent of the Sting sport. So what can happen if you have functions that are very similar is that the agent miscalculates and calls the wrong function in this case, and then answers with the wrong answer to my question. So in these instances, you also need to be aware of how similar are my agents, how similar are my functions, and then you need to embed control mechanisms to make sure that the proper things and the proper tools are called for certain types of actions. All right, so that's for the demonstration here. Let me quickly show you how this is implemented when you just use control generation. So we have our repository here. We will be sharing the links so you can also inspect the code and set it up and test it yourself. Essentially what we have is under agents, we have our agent definitions. And for the agent definitions, what we do provide is the response schema in JSON. So this is what we use for control generation to really say, okay, this is what I'm expecting as an output from you. Always stick to this JSON output format. The other thing is we're giving a persona, we're giving the instructions, and then we're handing over the tools. So in this case, what we do for tools is we're defining, let me go to the Python functions in here. So we're defining different Python functions, analyze image, or a Python function to search through the manuals that we have on Vertex AI search, and are giving these to our agents as just a function name along with the arguments and the doc string. So that's enough for the agent to understand what the function is doing and also to understand how to call them. And the similar pattern for the other agents. What we then did here, because we didn't rely on a function calling, we didn't rely on any abstraction, so we needed to handle everything manually. Meaning, of course, we need to have a prompt to really let the agents know how to work with the functions and how to work with the tools that we provided. So what seems to work very well is, of course, giving some few short examples of how this could look like. So in our case, we always wanted to output in a format that it says, what is your understanding? So that we have some sort of chain of thought reasoning as well. And we want it to give out the function name. We want it to give out the function arguments so that we can handle it. And also a Boolean, essentially, for us to know, does the agent need to execute a function, true or false? So that in our agent system logic, we can execute the function automatically if it's set to true. And I'm giving it a few examples for you to understand and to handle the tools for us. All right, before handing over, let me also look into the orchestrator here. So this is how the main orchestrator is set up. Essentially what it does, it automatically, like dynamically discovers all of the agents that I'm defining here in my agent definitions. So the only thing I need to do is I can define a new agent in the same format, and the orchestrator will be aware of the agent and from the descriptions also understand what the agents are doing. So it's fetching these agents, and then it's the orchestrator's task essentially to understand, do I need to call an agent, or can I just answer a question myself, or is maybe the question out of scope for the use case I'm handling? All right, that's for how everything is implemented. And with this, I would like to give over to Heiko.
Thanks, Meltem. So as Meltem already mentioned, there are many things that you need to take into account when building your agent system, like the function calling, for example. And I want to quickly show you what are the challenges when you build your multi-agent system, and how can you start testing not only once your agent system has been built, but also throughout the process, during building. How can you test and evaluate your agents? Whenever you've worked with large language models, you know that small inputs, small changes can change things very quickly. So that's what we're going to be looking at today. But first, let's go to Paris. Kanch already set the stage in, she was looking for the Shangri-La in Paris. And let's say we have our multi-agent trip booking application set up. And me as a user, I'm like, yeah, book me a Paris, include flights, hotels, rental car for these dates. And the request goes to the planning agent or the orchestrator. And basically, the planning agent will come up with a plan and then send out individual tasks to the different agents, the flights agent, the hotel agent, rental car agent. And all these agents also need to speak with one another, because obviously, your flights, when they land, will determine when you pick up your rental car and so on. And for any one of you who have already built like these kind of agent systems, you might be familiar with the challenge that when you ask your agent system to book a trip to Paris on these dates, it might come back and say, sure, here's your trip to London on a very different date. And you're like, well, but okay, so something didn't quite go right, but what is it? And the challenge with multi-agent systems is that there are so many different points of failure or potential points of failure because they're so complex. So you need to test multiple scenarios before actually finalizing the architecture. And in order to do that, we need to take a more granular step. We need to, once we are starting to build our agent system, not look at the overall system, but maybe we look just at a single agent and test the functionality of that single agent. So let's have a look what that looks like. In our multi-agent system, let's only look now at the planning agent who gives a task to the flights agent, and the flights agent is the single agent that we want to evaluate. But even with that separation, with that isolation, we still have actually multiple points of potential failures. So the planning agent, says to the flights agent, book me a flight to Paris on October 21st. And what does the flights agent really need to do? So they need to understand the request, then select the correct tool, extract the correct parameters, create and send a valid API request to whatever API is used in the background to check and book flights, understand and act on the response, and communicate that all back to the planning agent. So as you can see, even with a single agent, it is actually still complex. You need to actually make sure that all these different actions that a single agent takes, that they work. You still have potential multiple points of failures. So let's get even more granular and isolate even more and look at just one thing that the flights agent needs to do. And the first thing, and one of the most crucial things any agent in any system, no matter what LLM, what foundation model, what framework you use, is tool selection. Every agent will at some point receive a task, needs to understand the task and select the correct tool and extract the correct parameters in order to fulfill that request. And that is what I want to introduce you today, is a tool selection testing framework as an example of kind of a unit test. So if we think about traditional software development testing, we can actually take these concepts that have been established and transfer them to agent testing. So as you might know, there are different types of tests in software development. There are unit tests, integration tests, and system tests. And the unit tests basically test a single function, a single class, or a single method in isolation and see if that function does what it's supposed to do. And then you move over to integration tests, where you basically test the interactions between these different functions and methods and modules of your system. And then you move to system tests, where you test the complete and entire application. And if we take these concepts to multi-agent systems, starting with a system test, that would be testing the entire multi-agent system. So you test agent collaboration, tool usage, you test the memory system, end-to-end workflows, very complex. But that will be at the end, just like system test in software development usually happens at the end. And integration testing would be taking one of these agents in isolation and basically check all the actions that a single agent does, such as tool selection, API calls, response passing, and selecting the next action. And the unit test here would be a single action by an agent, such as tool selection, but tool selection is only one example. It can also be creating the API request, sending the API request, passing the API response, and selecting the next action. So in that sense, you will have to have, once you start building multi-agent systems, you will have to have several unit tests in order to make sure whenever you change something in your agent system, that the agents still perform these basic actions accordingly. So let's have a look at one of these unit test frameworks. And as I already mentioned, the unit test we're going to be looking at in particular is the tool selection of an agent. So we want to make sure that given a request and given several functions and tools that an agent has at its disposal, that it always selects the correct tool. And for that, I'm actually gonna move over to the demo. So here we have the tool selection tester for GenAI agents. I know it's a mouthful, but basically what happens here is, looking at the architecture again, we have a test data set with sample queries and a ground truth, which means this is what we want the agent to do. We have a tool registry with tools in there. Together with the test data set, the model, the foundation model, will create a response based on the query and the tools that it has available. We then take these model responses and compare them to the ground truth and check if they are identical. And if yes, that's great. And if they're semantically equivalent, that's also great. So basically, we're also going to use an LLM as a judge, basically just to check if the responses are not one-to-one, perfectly 100% identical, they could still mean the same thing. We will see an example of that as well. The test data set consists of several different sample queries. One is for just straight up tool selection tests, where we give the model a list of tools and a query, and we want it to select the right tool. But we also have in this data set some other queries, some which require, some queries that might require clarification because some information is missing. Error handling tests, direct response tests. That's what Meltem mentioned earlier as well. Sometimes the model doesn't need to actually perform a tool in order to respond to a query, and we want that to be the case. And also not supported tests. So basically, the list of tools might not be enough, or the query that the user gives to the LLM cannot be supported with the tools available. Let's have a look at the functions actually. So this is how we initialize the function registry and register all the functions. So you can see there's like get weather, get current time, translate text, calculate route, and so on. So we want to give this list of functions to the model, and then we give it also a query such as what's the weather like in New York, and we say the ground truth is it needs to call the function get weather, and it also needs to extract the location New York. Another example of these queries, one where we, for example, expect the model to not call a function, so function call is null. We expect it instead to directly respond to the user query without calling a function. And there's other examples in the repo. You can browse it at your own time. Let's quickly run the test based on roughly 120 queries, which we can do in parallel. So it's processing all these different queries. You can also see it runs then semantic evaluation for some of the test cases. Again, that is when the answer is not 100% identical, we still want to check if the answer is still valid. And at the end, we get some stats here. So it's done well on the tool selection, not so much on the direct text response. And if we look at the folder, the results folder, we see here for every one of these queries, we see the results. What's the weather like in New York? We expected get weather arguments location New York, which we got. And in the semantic comparisons, we also see sometimes, again, as I mentioned, it's not 100% identical. So here, for example, the expected text for an email agent was confirming our meeting on March 15, 2024. And the model actually says this email confirms our meeting on March 15, 2024. So although the two texts are not identical, they're still semantically equivalent. And the LLM as a judge also explains why he thinks they are semantically equivalent. All right. That is basically the tool selection testing framework. Have a look through the repository. It will be made available to you. And with that, I'm going to hand it back to Kanch.
Oh boy, that was a lot of information. We thanks Heiko and Meltem. We went from, learning about how do you do this with function calling, control generation, grounding, reasoning engine. There's a lot which is out there. So please feel free to look at the resources. Some of them is just personal projects which has been put together. We do need to bring it to the main repository. But you like as Meltem and Heiko had walked through, there were a lot of challenges which we were sharing. That's based on the experience working with customers and building our own agents. So the question to ask would be, the first question would be, asking, do we need an agent, or is it a foundational call? Is it needed? And if yes, then do you really need a multi-agent? Could it be a single agent? If yes, then what are the agentic capabilities you're looking to bring? We suggest starting where the users and the business needs are before figuring out the technology stack. The products, the models, the strategies, the patterns, all are going to evolve as it goes. So I would rather much focus on what is your actual business use case and the needs or the impacts you're trying to drive. Experimentation starts very small, as Heiko was walking through. He went from multi-agent to single agent to a single task. And he just talked through like one evaluation strategy. And there's a many more to, even think about. So identify what your, key building blocks are. Even for a single agent, figure out what the operational needs which are needed. How do you establish observability, monitoring, tracing, logging, things like that? So there is a lot to uncover. Whatever you saw today are something which you could experiment, create more agents for you to be able to test it. There are a lot of content and resources which we will be sharing. And again, this will be updated because we are going through some changes, but the product docs are available as well for you to be able to get most up-to-date information. Now we go to QA, and we do have a feedback form. We would appreciate if you could take a couple of minutes to share your feedback. We realize feedback is a gift, and we hope you enjoyed the session, that you give us some feedback. Gift. Yes, so let's go to the questions. Heiko, maybe you can answer this. In the evaluation you walked through, you are still using LLM as an evaluator and semantic matching. Which means that if we do it again, we get different results regarding the nature of LLMs. What are your thoughts on that?
Yeah, so it actually turns out that LLMs are quite good at semantic evaluation. So every time, my gut feeling tells me every time I would give these two sentences that we saw, one is, I confirmed the meeting on March 24, and the second text was, this is to confirm our meeting on March 24. I would guess that a Gemini, which I used as LLM as a judge, will always give the response that these two sentences are semantically equivalent. So I don't have too many concerns on that particular front, because LLMs are very good these days on basically evaluating whether two statements are semantically equivalent.
Okay, I hope it answered the question. And okay, so next question is from George. Would inference time testing be justified, suitable for mitigating issues like loops or other issues in real-time systems and informing users? Melton, do you want to, take a stab at the question?
Sure. Yeah. Sure thing. I would say yes. So the thing is, there's a few things you can do. I would say a priori when you build things up in the back end. That you say, okay, I'm giving a max loop counter of 10, for example, but that may be not ideal. So I would say, there's a lot, as you saw, there's a lot of failure boards. There's a lot of stuff to be tested when you work with agents, and especially when you work with multi-agents. So I would also say there's a lot in these tests that makes sense for inference type testing. Maybe some of them would be, I would put them outside of the box. Like, for example, for the test that Heiko also walked us through, some tests that you also work on while you're developing. But when you're really moving to production workloads, then I would say the answer is definitely yes in this. Is there anything, Heiko, you want to add into this as well?
No, I think that makes a lot of sense. I think you can also obviously then start thinking about tuning your models, basically train them on certain use cases that you have seen in production where they take too long, they go into an endless loop, capture those use cases, and basically tune your LLMs based on those. So the ways how you can tackle these kind of challenges are endless, which why I always try to come in, get it back into like testing and evaluation, because once you then fine tune your model, then that might break other things. So yeah, I think it is definitely warranted to do that.
Great. Those both are good questions. And there was one feedback to have a quick start or a code lab session. Completely agree. This is still like, in the process, as you could see. More the space itself is evolving so much that it takes time to do things. Um, Maybe Malcolm, for you, what if I have thousands of tools? Can or should I include all of them into my agent system?
That's a good question. I think I also saw one of our moderators already catching that one, but I can do a +1 on top of that. Essentially, it doesn't really make sense to load thousands of tools into one LLM because there's a lot of research, those experiments that indicate that the agents tend to break if you load it with too many tools. It tends to be confused as well. We also saw it in our demo. I mean, we didn't have in the supply chain demonstration, we didn't have too many tools. But even when tools were slightly similar, it got confused for them, right? So what I would say in these use cases, if you have a lot of tools, it makes sense to explore a tool registry so that you have all your tools in one place. They also enable shareability and reusability. And then what you can do essentially is you could have your developers, so really the agent builders, select them. So essentially you could have a filter on top of your tool registry and then have a checkbox or of some sort and then have them manually select the tools that are fitting for an LLM. Or what you could also explore, there's a lot of work popping up in the field of tool rec, essentially having a rec pipeline for your tool registry so that you can autonomously find the best fitting tools for your use case and then just feed those tools to your agent so that you really avoid putting in too much stuff into your agent.
Yes, I completely agree. And I think I see another question with respect to similarly, what is the best practice for number of tools for an agent? Similar question. It's better to understand and disambiguate how less you can with the number of agents or similar agentic tool features, so you could be, as accurate as possible. We are closer to time, so we'll have two questions. One maybe Heiko, is it possible to use other FMs for specific agent in multi-agent workflow?
Absolutely, yes. And that is again something that should be explored. Some agents might be quite simple in what they do, so you could use a much smaller model, Gemini 1.5 flash 8 billion, for example, to reduce costs and reduce latency. And again, that would mean once you change a model, you would have to run your tests and evaluation once again, because that will change your overall system's behavior. But yeah, absolutely.
Yes, thank you. The last question, when we wrap it up, Melton, how do we identify and handle hallucination?
That's a really tricky question. The thing is, it really comes down to, especially in agent and multi-agent, for you to identify where does it happen. And it's generally, the reason why it's hard is because if we knew, like if we could catch all hallucinations, we wouldn't need the agents, because that would mean that we know the ground truth to what we're seeking, which in reality we don't. So essentially the answer is, the easy answer would be we cannot catch at 100% rate the hallucinations. But what we can do is, as Heiko also mentioned, we can first start testing all the agents individually to see, is the tool selection working, to really identify what could break and make sure that these parts are robust, right? So let's take a tool, for example. If an agent executes a tool, it needs to first identify the proper tool, then it needs to populate the proper arguments, then it needs to, like the system needs to execute the tool, the response needs to be fed back to the agent, and then the agent also needs to understand the response from the tool, right? And then interpret it correctly and give it back. And if you have multi-agents, then the next agent also needs to interpret it correctly to give the proper answer. So there's a lot of steps, a lot of different failure modes where you can potentially have hallucination. So what I would recommend on doing is be sure to always have a test-driven mindset. So test each step that you have in there, make sure that you have a robust testing pipeline so that you can catch whenever something is off. Because when you also build testing while you're doing the experimentation and while you're doing development, usually you get a good test set as well that you can also use to see for monitoring if something is off, if the behavior has changed of your system compared to how it was behaving in test and development scenarios. So that's, I think, a good indicator that you can start with, that you can catch. But yeah, again, the easy answer is you cannot 100% catch hallucinations, sadly.
One thing
My
I would add,
colleague tells me, sorry, go ahead, Ed.
just a quick one I would add to that is, implement your agent system so that it shows you the paper trail. Get as many references as possible in the answer, ideally embedded, so that you can look up the crucial information that it basically claims that it has found.
All good information. One of my colleague tells me this, like, hallucination is a feature, not a bug. So you just need to define with that feature. With that, we end the session. Thank you once again for joining. And there's a lot of information here. We hope you find it useful. And we are looking forward to sharing things in the future. Thank you.